Hello everybody, I hope everybody is well and you guys doing okay. It looks like in next few weeks we will meet online and we will take exam or quiz online. Most likely we're going to have our second quiz online by next week. I will email you guys regarding that. But for now, this will be my first video for you guys. I just want to see you guys or you guys see me, and I use my iPad to go over a new topic. I try to be on the same style that I taught you guys in classroom. In the first video, you might see a jump from one app to another app because I'm just trying to figure it out how to go from the page of the book to one app here and then make everything in one smooth video for you guys. So I do my best and that's it. So after this video you're going to see a couple examples I'm going to solve, and then you will see more videos from me, and I will look for your feedback. Email me. Also follow all the discussion on the Canvas. Thanks. I just want to show you guys what chapter we are. So far we are in chapter 2, and on Wednesday we complete 2.2 about the circle, unit circle. We talked about 2.4, which is graph of sine and cosine, but I would like to start my first video from 2.3, so property of trig functions. And on 2.3, I am, so you should see this page inside of my MATLAB. What I'm going to exercise, which is page 142. I think page 142, they have some good example. I would like to solve a couple questions that we went over it on in our last class on Wednesday. I would like to go over number 27 and number 43. All right, so I'm gonna take a snapshot of the page. I open the page here. So we are working on number 27 and number 43. So number 27 is just asking us if sine of theta is more than 0 and cosine of theta is negative, then name the quadrant in which the angle theta lies. So let me have another layer. All right, so I'm going to solve number 27 in this block. Oops. So, sorry about that. So number 27. So definitely we need to draw a circle. So I'm going to make a circle. We don't know if that's a unit circle or not. So any type of circle with x and y axis. This is x, that's y. You know, on the unit circle, we started that x represent cosine and y represent sine of an angle. We learned that this direction is plus, the other direction is negative. We have 0, 90 degree, 180, 270 or 3 pi half, and 2 pi. So let's see how do we find the theta here? They said sine of theta is positive So sine of theta, on the unit circle we learned this is y, but for any other circle is y over r. But let's assume that this is a unit circle. So this will be our sine. So the y-axis represents the sine. This is 0, 0. If you go up, is positive, and this direction would be negative. So y is positive on quadrant 1 and quadrant 2. So this is positive, sine is positive here, also sine is positive there. Now let's look for cosine. We have cosine theta is negative or less than 0. Cosine, if cosine represents the x-axis, so from 0 to this direction will be positive, to other direction will be negative. So x is negative on quadrant 2 and quadrant 3. So we have quadrant 2 and quadrant 3, cosine is negative, and we have quadrant 1 and quadrant 2, sine is positive. Therefore, in quadrant 2, theta should be on quadrant 2, which is sine is positive, cosine is negative. Also, you can see that here is a double shaded. So this will be the solution. Pretty basic question, but has very, I don't want to say an easy question, but it's something that you should know before move to the new section for homework. So I hope you guys love this question. Now let's solve another example. So let's go to number 43. So number 43, I'm going to solve it in the yellow board with the color of light gray. Oops, now let's solve it in the gray. Let's go back. Okay. All right. So this is a type of question that you will see in chapter 3, chapter 4, and chapter 5. You will see this type of question on the quiz, exam 1, exam 2, exam 3. So it's very, very important. So in order to solve, find the exact value of each of the remaining trigonometric function. So it's given is sine. So we have sine of theta. So sine of theta is given. We are looking for cosine theta. We are looking for tangent theta. We are looking for cotangent theta, secant theta, and cosecant theta. All right, in order to solve this, the first step is you need to make a circle. Well, not a box, a circle. We make our x and y. I would suggest start labeling. So labeling means we're going to say this direction is plus, the other one is negative. We have 0, pi half, pi, 3 pi half, and 2 pi. We know this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So sine of theta is given 12 over 13, and we know theta is in quadrant 2. So somewhere on this part. So I'm going to randomly make a, I'm going to call, for example, this. So that's the example. I just randomly made this as theta. Any theta that is in quadrant 2, it works. But you know, in order to make a right triangle, we need to deal with the reference angle. The reference angle will be here. So this will be a reference angle. We love this theta. So we make a right triangle. Now we have sine of theta. Sine of theta, in your note sheet, you have y over r. Here is given 12 over 13. So r is 13, y is 12. So you know the first thing we should do, we need to solve for this unknown. We have to solve the triangle. So therefore, this is our unknown. I'm going to call it x, and we have to solve for this. When you solve this triangle, when we solve this right triangle, that means we can answer all of them, because we know that cosine of theta is x over r, tangent of theta is y over x, cotangent is x over y, secant is reciprocal of cosine, which is r over x, cosecant is reciprocal of sine, is r over y. So now let's solve the triangle. We solve it with Pythagorean theorem. So we have x squared plus 12 squared equal to 13 squared. Let me change the colors to lights. So we have x squared plus 144 equal to 169. X squared equal to 169 minus 144. X squared equal to 25. X will be plus minus root 25, which will be plus minus 5. Now you look at the quadrant. On this quadrant, x is negative. So x is going to be negative root 5. No, just negative 5. Sorry about that. All right, we solved the triangle. Now is a fun part that you will get point for it. So cosine theta, negative 5 over 13. Tangent theta, y over x, which is negative 12 over 5. Cotangent theta is negative 5 over 12. Secant of theta is 13 over negative 5. And cosecant will be 13 over 12. So very, very important question. Watch this video as many times as you want. Try to solve, for example, number 44. So there's a lot of good example on page 142 of your book. It would be excellent if you go over all of them. All right, I know this video got kind of long video, but in next videos I will make sure to be less than 4 minutes. All right, thanks, bye.